Okay, welcome back. So our next lesson is about perpendicular and parallel lines. You'll see them a lot in the real world. They're used often in places such as buildings, and there's a picture of such a building here where you can see lots of parallel and perpendicular lines that are happening there. So because of this, it's important to know these lines are really accurate, because accuracy is what adds strength to buildings and things like that are made in the real world with this type of maths. So just a reminder that perpendicular lines meet at a right angle, and parallel lines are lines that are equidistant or the same distance apart for their entire length and never touch. So remember those two different things. So continuing the work we've been doing with linear graphs and gradient and all of those types of things, we can actually use this to make sure lines are parallel or perpendicular, which makes it really handy when accuracy is super important. So let's have a look at some of these rules. So if two lines are parallel, it makes sense that they have the same gradient, the same slope. They're never going to touch if the gradient's the same, and that's what we want with parallel lines. So they never touch, something we need to remember. If two lines are perpendicular or at right angles, they have two different gradients. So we're going to call gradient 1 M1 and gradient 2. And if we multiplied those two gradients together, we'd actually get -1. Or we can rearrange that formula to actually find the gradient for one of those if we need to. So we're working with here the negative reciprocal or inverse. So remember, a reciprocal or an inverse means it's over 1, and in this case it's a negative. So there's an example of one here that shows you that. So if the gradient of one line is 4 and the gradient of the second line is -1/4, which it must be because it's a negative reciprocal for it to be perpendicular, then we can use that to find out something else about the lines. So let's have a few goes at some examples of some. Okay. So find the equation of the line which is parallel to the line y equals 2x plus 3 and passes through the point 0, 1. We need to plot both of these lines to prove this, and we can use any method we've learned so far. So I'm just going to write some things down first that we know. So the standard equation of the line is y equals mx plus c. I'm just going to remove the keyboard from my device. Okay, so because of that, and what we're working with this time is y equals 2x plus 3, we know that this value in front of the x is our gradient. So in this case, m equals 2 for the line that is parallel that we need, because the lines are parallel. So because they're parallel, we know the gradients are the same. Because the gradients are the same. So we can substitute that into the equation we're trying to find straight away. So y equals 2x plus c. So sub it in to general form. Now, we need to know what c is. And we actually know what c is because it tells us that up here. So our c is our y-intercept. And we've actually been given our y-intercept here. So in this case, our y-intercept is 1, and we can sub that straight in as well. Y equals 2x plus 1. So as far as we're concerned, the gradient of the line that passes through 0 and 1 and is parallel to the line y equals 2x plus 3 must be y equals 2x plus 1. Now, I said you could use any method you've learned so far to plot both these lines. So I think what I'm going to use is the gradient intercept method. So using the gradient intercept method, I need my gradient, which is rise over run. And I know in this case that my gradient is 2. But I need to turn that into a fraction, so I just make that over 1. My y-intercept I know as well because we were given that So that is 0, 1. So if I plot my y-intercept and then I use my gradient in the rise over run form, I'll be able to plot my second line. And I'm going to do that with both my lines, actually. So let's draw a scale onto these axes that are here. Okay, please use your rulers. So 1, 2, 3, 5, 6. Now I'm not sure at this point how far I'm going to go up, so I'm just going to draw a few. I know 3, 4, 5. It shouldn't be more than that though, I wouldn't think at this point. Y and X. So let's start by plotting our first line. So our first line, the coordinate that we know here is 0, 1. So that's what I'm going to plot first. So that's my y-intercept. And I know that it's going to be rise over run. So it's going to be the same situation here. So I'm going to rise 2, 1, 2, and I'm going to run 1. All of that's positive. So we're heading upwards and to the right. So my second point for this line is going to be there. And I can draw a line straight through those. So what I have just plotted is the line that we found, 2x plus 3. Now, for y equals 2x plus 1. For y equals 2x plus 3, we've got the same information here. So our m, again, is 2 over 1. And our c-intercept in this case is 3. So that's 0, 3. So we can plot that as well. And it's going to rise 2 and run 1. So our second point will be here. And we can draw a line through these points as well. Now, if your line's beautiful and accurate and you've used a ruler, it will be very easy to see that these lines are parallel and are never going to touch. So, same gradient, different intercepts are what is going to give you your parallel lines. Okay, now the next one we're going to do is work with some perpendicular lines. So it's got find the equation of the line which is perpendicular, so remember that means at right angles, to the line y equals 3x minus 2 and passes through the point 0, 3 and plot them to prove it. So y equals 3x minus 2. That means that the gradient here, m1 for this line is 3. Now I know it's perpendicular, so I'm going to have two different gradients here. They're not going to be the same, and we need m1 and m2. So a line, so to be perpendicular, let's write the rule down. So, and these are rules you just have to learn. So be perpendicular to this line, we can use the formula m2 equals -1 over m1. So we can substitute that in and find it. So that means m2 is going to be -1 over 3 in this case, -1/3. Now, we know the c-intercept, or c, or the y-intercept rather, c or the y-intercept. We've been given that here. So in that case, it's 3. So we've got enough to actually write our new equation. So the equation of the line that is perpendicular will be y equals -1/3 x plus 3. That equals the perpendicular line. Now, we also have to plot, but I thought I might use a different method this time. This time I'm going to use the x and y intercept method, just so that we revise something that we've done before that's a little bit different, and you need to remember all of these once. So just a reminder, using the x and y intercept method, you substitute 0 in for your x and y values to solve for the other point. So I'm going to do each equation separately. So first one is y equals 3x plus 2. So to find the y-intercept here, I'm going to let x equal to 0 and substitute that in. So that's going to become 3 times 0 minus 2, y equals -2, which of course gives us the point 0 and -2. To find my x-intercept, I'm going to do the same thing, but this time I'm going to let y equal to 0, which is going to give us 0 equals 3x minus 2, 3x equals 2, x equals 2/3. So our point we're working with here is 2/3 and 0. So that's our first line. Now I'm going to do the second line as well. Same method. So to find the y-intercept, I'm going to say let x equal to 0, y equals -1/3 times 0 plus 3, y equals 3, which is of course 0, 3. And to find our x-intercept, let y equal to 0, 0 equals -1/3, x plus 3, 1/3, x equals 3, x equals 9. So that point is 9 and 0. So now it's easy enough to plot because we've got those two coordinates and we can see for sure that they are perpendicular. So again, using a ruler, it's a very smart plan because then your graph will be much more accurate than mine. So y and x now. I need with my x values to go up to 9 and at least to 2/3, so that's going to be fine if I just start in the positive quadrant. But with my y variables, I need to go down to at least 2, -2 rather, and I need to go up to +3. So I need a bit of my negative axis for my y values. So -2, 2, 4, 6, 8. So even though I've drawn more points, I'm only going to mark every second one just because it's small and it'll make it easier to read that way. 10, 12. Okay, so now I'm ready to plot my points. So my first line is 0 and -2, so that's going to be down there, 0 and -2, and 2/3 and 0, so that will be, it's hard to be exactly accurate for that one, but that will be somewhere near there. So that is y equals 3x minus 2, and we might go a different color for the next one. So let's draw that in, say, red. So our next points are going to be 0 and 3, which will be here, and 9 and 0, which will be here. And let's draw a line between those. And again, if you're using a ruler, you'll be accurate, and it will definitely look like a right angle, which it doesn't really look like, but it should. -1/3 x plus 3. And you'll be able to see that they are perpendicular to each other. Okay, so your turn is to work through exercise 4i and do the questions that are set, and then you need to watch a linear modelling screencast for the next lesson. See you in class.